Hi.
Hello,
Hello.
happy
Hello.
afternoon. I'm Paula Maccabee, and I'm WaterLegacy's Advocacy Director and Counsel. And the way this format is going to work today is I'm going to do a presentation giving you some context about sulfate and wild rice and mercury. And then I'm going to turn over the program to Eric Morrison. So I'm going to tell you a little bit more about Eric. And Eric Morrison is the co-founder and chief scientist of a startup called Superior Nano, which is a biotechnology startup on the North Shore. And he has a PhD, having completed both requirements for organic and inorganic chemistry. And he has authored some more than 20 articles and peer-reviewed publications, and is an inventor on about 60 US patents. And for a long time, Eric worked as a research chemist, including for huge companies like 3M and Ecolab. And Eric, along with a few other really brilliant scientists and mathematicians, founded the Northern Lakes Scientific Advisory Panel. And that's where they go and collect and analyze water samples and review scientific literature and provide a scientific perspective on many of the issues that face Minnesota in terms of pollution. And what's really important here is that Eric in particular has broken new ground, because the Minnesota Pollution Control Agency has always sampled sulfate, and sometimes they've required companies to do that, but the companies don't necessarily make their data public. And for the first time in Minnesota's history, Eric Morrison and other folks at NLSAP, which is Northern Lakes Scientific Advisory Panel, did sulfate sampling and went through the horrible process of teaching the MPCA how to work with citizens so that data could be uploaded and be available on the formal website. And so what I'm going to talk about is why this kind of this citizen science is so important, and about the effects of sulfate. And then Eric is going to take over the next half of the presentation and talk about some of his actual experiences and what it's like to sample for sulfate, and how it's significant in the northern Minnesota, not just for the Lake Superior watershed, but also for the boundary waters and for the health of the ecosystem. So let me see if I can figure out the technology. What I also want to say is I'm not sort of asking everyone to introduce themselves, but I really do want to hear from you. And Sophia Patain, who's our engagement coordinator, is going to be monitoring the chat. So at least when I'm talking, if you have a question in the middle, just put it in the chat and Sophia will ping me, or or raise your hand and she'll notice that, because I want to make sure that we have time to have a dialogue, not just after Eric and I give our presentations, but anytime you have a question. So I'd like to get started now with some basic information and see if my screen works. Let's see. All right. Let's see if that's the first one. Okay. I am not a scientist or really that good at technology in general, so just give me a minute or two. There it is. Can everybody see that?
Yes.
Okay. And you can talk too. So I want to talk about sulfate pollution and wild rice impaired waters. And you can see a picture here of Lake Superior, and also a picture, this is taken by the Fond du Lac Band, of wild rice abundance, because wild rice is kind of the canary in the coal mine. It is not that sulfate doesn't affect other ecosystems, but wild rice tends to be the most susceptible because it's an annual plant. It's not a perennial. And each season it needs to be renewed based on the quality of the water. And what is sulfate pollution? This is a picture from a hard rock mine in the western United States. But most areas of Minnesota, particularly northeastern Minnesota, are naturally low in sulfate. And that means wild rice historically has thrived there, and also an entire ecosystem of benthic macroinvertebrates, which are basically little bugs, and fish that depend on a low sulfate environment. And today, taconite mines and coal plants are the largest dischargers of sulfate in Minnesota. But the threat for copper nickel sulfide ore mining is that it would discharge massive quantities of sulfate into waters that the natural ecology has low sulfate. So this is a really important thing. The current problems that we're seeing are because of taconite mines. And so taconite mines are not harmless to the ecology either. And then copper nickel sulfide ore mining would discharge massive quantities of sulfate. And mining is a source of sulfate pollution. That is inherent in the geology, because copper and nickel ores are bound up with sulfide. And when the mine is blasted and the rock is removed and pulverized, that rock and that sulfide, that sulfur material, gets exposed to water, it gets exposed to oxygen, and it forms acid mine drainage, and also forms a chemistry that leaches the toxic metals out of the mine. So this is a picture of sort of where the, I don't think I have a, can you see, when I use my pointer, does it show up on the screen, or is this just for my own benefit? Okay, so right here you can see is the orange is the Duluth complex. And this is a disseminated ore body, which means it's a very huge area, but a relatively low percentage of copper nickel metals. And what that means is there would be a huge wetlands destruction, forest destruction, and huge amount of waste for every bit of ore that is mined there. And the amount of ore is approximately 1%, whether it's twin metals or polymet. And so you can imagine is that we're looking at mines where, after all the destruction and the energy used, that approximately 99 or even more than 99% of what would be left over would be waste. Now over here, number 5, this is the Talon Metals mine. This is a different kind of mine because it is what they call a massive sulfide mineralization. It's an older geologic formation, and the concentration both of the nickel and the sulfide is much higher than the Duluth complex, which poses an even more significant risk, perhaps, for generation of sulfates and release of sulfate into the environment. You can see these little numbers. There's polymet, there's twin metals, which is, at least for now, sort of off the plate, but it's really important to see, you see numbers here, 3 and 4. 4 is tech and 3 is encampment. And anyone here who cares passionately about the boundary waters, the tech project is now being combined with the polymet project under the ownership of Glencore. And the pollution from a mine located in the area of the tech deposit would be flowing into the boundary waters. So all the concern that we've heard about with twin metals being in the boundary waters, that concern has not gone away, because even though most of polymet's pollution is going to head towards the Lake Superior watershed, if you look at these potential and becoming increasingly bound up with Glencore and polymet mines, this would be pollution for the boundary waters, Canoe Area Wilderness, as well as for the Lake Superior Basin. This is an important polygon over here on this side, because this red line is the outline of the 1854 Treaty Authority. And so it's important in thinking about mining and also the impacts of sulfate pollution, that the impacts of sulfate pollution are likely to be disproportionately affected. There are tribal resources of the 1854 Treaty Authority, namely the Ojibwe people. And these tiny little squares, this is the Fond du Lac Reservation, this is the Net Lake Reservation, and over here is the Grand Portage Reservation. All the area that is not covered by those tiny little reservations are areas where the Anishinaabe people have a treaty reserved right to hunt, fish, and gather. And that depends on having a thriving and clean ecosystem. And a cautionary tale, this is based on national studies, that every sulfide mine in a water-rich environment has resulted in acid mine drainage and or toxic metals pollution of surface and or groundwater, which is a track record of 100% failure to protect water quality. And all the areas we are discussing, whether it's the 1854 Treaty Authority area, or whether it's the areas slated for potential mines in the Duluth complex, or whether it's the Talon Metals area, the Tamarack area, these are all water-rich areas with a high proportion of wetlands. I'm hearing somebody's microphone, so. All right, and then here's just some background. It's really important to understand sulfate and the protection of wild rice. Many times we believe that whatever science we're doing today is the best science. But John Moyle did science the old-fashioned way. And he did field research. And he did field research from the 1920s to the 1940s. And what he discovered by that painstaking in the field research is that no large stands of wild rice exist in waters with more than 10 parts per million of sulfate. And in fact, there was no wild rice at all in water bodies with more than 50 parts per million. And you can see this is a recent map. And the colors are the areas that have lower sulfate, which means below 10 parts per million. That's where the findings are that the DNR has found wild rice locations. And if you get above 10 parts per million, the wild rice thins out, and then at the higher levels simply disappears. And Minnesota, once again, if you got your microphone on, please turn it off unless you were talking, okay? Minnesota adopted a federally approved 10 parts per million wild rice sulfate standard based on John Moyle's research in 1973. And the EPA approved it and looked at the science. And the Fond du Lac and Grand Portage bands also long ago adopted this 10 part per million sulfate standard. And for decades, the Minnesota Pollution Control Agency enforced it once against a coal plant. And there was so much political blowback after that, that for a long time, the Pollution Control Agency simply refused to enforce the standard and pretended it wasn't on the books. And the tribes working with the EPA in the context of the Polymet environmental review, and then an expansion of a US Steel environmental review, the EPA basically said, Minnesota, you have to enforce the wild rice sulfate standard. And no sooner had that happened than the Minnesota legislature in 2011 funded a task force, which I sat on and Nancy Schultz, the Fond du Lac band, sat on for about 6 years, meeting like constantly. That task force was intended to find new science that would support a change either to get rid of or to weaken the wild rice sulfate standard rule. Let's see, let me see if I can get that to work. Okay, why isn't this working? Next slide. We'll do this. And just as a little bit more background, I know most of us have all eaten wild rice, what the Ojibwe call manuman, and I think the correct way to pronounce that, P-S-I-N, is pshi, and that's the Dakota or Lakota word for it. Wild rice is an annual plant that grows in lakes and stream sediments. It's a bioindicator for clean water. It is food and habitat for waterfowl, migrating birds, wildlife, and fish. It's a healthy, high-protein, sustainable food and Minnesota state grain. And it's culturally and ecologically and economically important for both Ojibwe and Dakota people who have reserved rights to gather wild rice. And despite the loss of wild rice in Minnesota due to development and farming and also due to pollution, Minnesota still has more wild rice than any other state. And here's some of the science. This is a picture of some of the science that took place. Much of it was led by John Pastor out of the University of Minnesota in Duluth. And initially, what the mining companies, the taconite mining companies, were telling us is that iron protected against sulfate. And what they said would happen is that the iron would get bound up with a sulfide that formed in the sediments, and the roots would, and the wild rice would be fine. And what we found out in the science is that the seedlings themselves didn't immediately suffer. But if you added iron to the sulfate, you would still have very serious problems. These black plaques on the roots would form as a result of ferrous sulfide reactions. And as a result, the next generation of seeds would be depleted. There would be fewer of them and smaller. So over time, the iron was anything but protective. And a lot of these tests were taking place in what they call mesocosms, which are large tubs, because it is not possible to manipulate a real environment and introduce sulfate. And what the studies found out is not only did sulfates, and here's the data for 300 parts per million, not only did sulfate kill the wild rice, it also doubled the mercury release from the sediments and resulted in a 6 times increase of methylmercury in water. And what's important about that is when the mercury is in sediments and it is still in its inorganic form, the form that comes out of the air pollution emitted by coal plants, it is not capable of being bioaccumulated and affecting living things. But once it becomes methylmercury, methylmercury bioaccumulates in the food chain. And so that at the very top of the food chain, a large fish like a northern or a walleye could have a bioaccumulation of methylmercury as much as 1 million times more than in the water itself. And as a result of the bioaccumulation of methylmercury and the fact that humans are at the top of the food chain, as are other animals like loons, there was a study done by the Minnesota Department of Health in 2011. And 1 in 10 infants in Minnesota's Lake Superior region were born with unsafe mercury levels. And that was over 1,400 infants that were sampled. And I asked some of our consulting physicians, well, what does it mean unsafe? And I was told by a psychiatrist, a child and adolescent psychiatrist, that the cutoff that the health department used is the same cutoff that the literature says would result in a decrease in IQ. And so the sulfate indirectly through the interactions in the sediments and in the environment is a real threat to human health. And then also, this one was more of a surprise to me. Sulfate loading in these mesocosms also released nitrogen and phosphorus. And what we see, there's a classic example of Lake Manganika that is basically an outlet for mining waste. And the level of sulfate has led to very strong algae blooms. And so you see that as an effect that on the ecosystem, not only because of wild rice, not only because of mercury, but also because of increased excessive nutrients that themselves can impair water quality. So what have we done as WaterLegacy to preserve the wild rice sulfate standard? Well, shortly after, once again, not only did the legislatures put this task force into place, but then in 2012, the Minnesota Chamber of Commerce, led by its mining industry advocates, they sued the state of Minnesota to block enforcement of the wild rice sulfate standard. And WaterLegacy consulted with the tribes, and we sort of concluded that the state alone was not going to do a vigorous enough defense of the wild rice sulfate standard. So we intervened, WaterLegacy intervened and got accepted as a party, and then we won the case in district court and the appeals court. So then the industry put most of its energy into this task force. And what was very troubling to me is the Minnesota Pollution Control Agency evolved their own position so that they were seeking to repeal the wild rice standard. And instead of having a clear 10 parts per million, don't exceed it, they were going to come up with a very complicated formula, which used factors like iron as palliatives, so that if you had enough iron, you really didn't have to cut your sulfate. So it was a very indefinite standard, and it also would have been very unprotective. And our primary allies in this were the tribes, but working together, we won a huge victory in 2018 in January, where the administrative law judge did something very unusual and disapproved the Minnesota Pollution Control Agency's plan and upheld the sulfate standard. And the chief judge, that was appealed to the chief judge, and the chief judge again said, this is the appropriate decision. And then what happened is, of course, the lobbyists went to the legislature. And in the spring of 2018, there were 2 bills that tried to repeal the wild rice sulfate standard. Heck with the science, heck with the process, we're just going to repeal them. And we did a lot of organizing, again, working closely with tribes. And Governor Mark Dayton twice vetoed bills to repeal the wild rice sulfate standard. So if you don't ever think of Mark Dayton, anytime you go out on the water and the water is clean, or you're eating wild rice, think of Mark Dayton, because if he had not repealed those bills, everything that we're talking about today that we've accomplished would not work. And then in 2021, Fond du Lac and the WaterLegacy, we sort of talked them into this, but it was fantastic. We appealed from a permit from a U.S. Steel Mintac tailings basin. And that was the first time we actually had a court rule that the sulfate standard must be enforced under the Clean Water Act. Now, as a matter of fact, because the Mintac tailings basin is an existing facility, we haven't really seen changes on the ground, but we have at least good precedent that is going to help us in cases like the Polymet case. And then finally, in 2022, after a lot of advocacy and a lot of tribal consultation, the US EPA agreed with WaterLegacy and the tribes that Minnesota's Clean Water Act program must apply the sulfate standard despite session laws. And we also in 2021, and this is the big one for, I think the next one, wait, next, more, even more exciting. So we got the laws from the court saying the wild rice sulfate standard has to be enforced. But the really important thing is that we began to get listing of wild rice waters that are impaired. And this is so important because once there's an impaired water, it creates an ability to limit new pollution from wastewater, but it also creates the ability to make a plan to clean up and restore the waters. And from about 2012 to 2022, WaterLegacy and the tribes worked with both the Minnesota Pollution Control Agency and the EPA to try and get some listing of wild rice waters. In 2013, the Pollution Control Agency put together their first tentative list of wild rice waters, and then the industry pushed back and they withdrew that. So until 2021, we didn't really ever have an official list of even a preliminary list of wild rice waters or any list of waters that were impaired. And this was a very elaborate process, but finally in 2021, for the first time ever, the EPA overruled the Minnesota Pollution Control Agency and listed 33 waters impaired due to sulfate that was harming wild rice. And 1 year later, the Minnesota Pollution Control Agency then, because they could feel EPA breathing over their shoulder, they listed 35 wild rice waters that are impaired due to excessive sulfate. And much of our work going forward is to make sure that these waters are not taken off the impaired list and to list additional waters. And this is important for wild rice, and some of the specific waters that NLSAP and WaterLegacy have been working to list is Birch Lake, because Birch Lake is kind of the gateway moving into the boundary waters and is a target of the pollution flowing north from the North Shore taconite mine. So that's a really critical water. We'll talk about it a little more. But what's so important, if we're thinking about the whole ecosystem, we're thinking about community and we're thinking about health, for many of the other impacts, the harms that are caused by sulfate, there are no standards. So even though there should be a standard also to limit sulfate, to avoid increases in mercury and mercury methylation, Minnesota has no standard. In 2006, the scientists within the Minnesota Pollution Control Agency said, this is important, this is a problem, it's a health problem, we need a strategy. Well, it's now 17 years later and absolutely nothing has been done to create a sulfate standard to protect us from mercury contamination. So the wild rice sulfate standard is basically the only standard we have. And so as a result, anything that the community does, the citizens do to sample for sulfate to protect wild rice is also protecting tribal resources, health, and ecosystems from mercury and from nutrient pollution. So here's a really cool picture. This was prepared by Amy Mirbeau, working with Friends of the Boundary Waters. And you can see this over on this side. This is a healthy ecosystem where phosphorus, nitrogen, and Hg means mercury are staying in the sediments. And you can see the wild rice roots are still clean. And mostly, of course, there's some interactions, but mostly the situation is pretty dormant. Now, what happens when you add sulfate is they called sulfate reducing bacteria, but when they say reducing, it means sulfate bacteria that change sulfate into sulfide. And these bacteria change sulfate into sulfide, and that chemical reaction causes the release of phosphorus, nitrogen, and mercury from the sediments, and also causes mercury to transform into methylmercury. So as a result of just one input, the sulfate input, there is an increase in algae and toxic contamination of water with algae blooms. And there's an increase in mercury and methylmercury. And you have here a graphic image of a fish. And we can imagine above that fish, we can imagine humans, we can imagine lumens, we can imagine any other wildlife that eats fish. So this schematic shows how just one toxic input can have cascading effects on the ecosystem. So why does community-based sulfate sampling matter? And you can see these are images. These are images taken from the Water Quality Technical Report of the Northern Lakes Scientific Advisory Panel. And these numbers are the sulfate sampling numbers that were taken. This here is the Dunca Bay, and over here on this side, this is Bob Bay. And both of these have small creeks that carry pollution from the North Shore Peter Mitchell pit or the North Shore mine. And you can see just looking at these numbers that the highest level of sulfate is closest to the pollution source, which is sort of down here below Google My Maps. And you can see it even more strikingly in Bob Bay, and that the pollution gets attenuated. But it's really important to notice that Birch Lake is a pretty large lake, and even with all this dilution, the effects of this taconite mine are changing the ecology, because naturally Birch Lake would only be maybe a 2 or 3 parts per million sulfate lake. And also community-based sulfate sampling matters because the law says it has to. There are Clean Water Act regulations, and here's the site for here, the 40 CFR section 130.7, all this stuff. But it basically says that states are required to consider all existing and readily available water quality data. And there's another specific part of the rule that says where the public or academic groups have reported water quality, that water quality has to be analyzed, and the organizations and groups should be actively solicited for research they may be conducting or reporting. Now, I will tell you that our experience with that, with the Minnesota Pollution Control Agency, wasn't really only that they were not cooperative, but that the system was not designed to accept any data from citizens other than sort of observation of the quality of whether you could swim there. And so we're hoping that we're making a change in how the Minnesota Pollution Control Agency will accept our data, Tribal Treaty Authority data, and then data of other organizations like Northern Minnesotans for Wilderness, and make that part of the official data. Because that's the data that both our Minnesota Pollution Control Agency and the EPA look at in saying whether a water body should be listed as impaired. And here's why it's so this picture here, and for some way, I think Lake Superior looks like a very hostile finger pointing at us. But this is from the University of Minnesota Duluth, because they work closely, the university works closely with tribes. And all these little dots represent areas where the tribes believe there's a really important need to evaluate wild rice sites of concern. And the white ones have no field work, and the red ones have field work that is just beginning now. So we can see that, you know, for our work as Minnesotans and as citizens, even just looking through this one lens of what's important to tribes, there is a great deal of work to be done. And then I want to get us back to Birch Lake, because I think this is our first test case of whether citizen science can change what is happening with impaired waters and increase the protection of a really important water body. Now, this quote, I only got this from the Pollution Control Agency after a Data Practices Act request. It was not made available to us, even those of us who commented. But it was very clear that in 2022, the EPA was just giving MPCA one more opportunity to list Birch Lake, because EPA wrote, and this is only one of the 10 places in the document they wrote it, that EPA is cognizant of the intense interest among tribal representatives and environmental interest groups in the overall health of Birch Lake, and the significant concerns these representatives have raised with respect to the adverse impacts of elevated sulfate levels on wild rice in Birch Lake. So the EPA did not approve MPCA, the Minnesota Pollution Control Agency's decision not to list Birch Lake. They just deferred it. So this is something that in the coming year will be very important to get that listing done. And then the other thing I learned when we were up in Duluth talking with tribal researchers, that new research suggests that if, as a result of cutting back on pollution or restoration work, that the sulfate is reduced, that there are seeds in the seed bank in the settlements and they can germinate. And so if we get waters that are impaired for sulfates, wild rice waters that have been decimated, if we get them listed as impaired and restored and the sulfate levels reduced, we're not just, it's not punitive, it's hopeful. We're going to be able to restore wild rice. And as you can see from the prior map and the sampling results, NLSAP now has developed expertise, not only in how to do the protocols of how to sample, but also how to work through the somewhat cumbersome procedures and get the data listed with the Minnesota Pollution Control Agency. And so any time that you are going out and you're working on citizen science and working with NLSAP, you can actually help protect wild rice and reduce the effects of sulfate on mercury contamination and improve Minnesota's health, our environmental justice for tribes, and our water quality. And so I really want to thank you for joining us today, for showing up, and encourage you to take the next step and become part of the process of citizen science and remain engaged in shedding light and maybe putting a little bit of a warm spotlight on the Minnesota Pollution Control Agency. Now, do we have any questions, Sophia?
We have one question in the chat from an attendee who's wondering a little bit about encampment. So this person knows encampment as a location on the North Shore near Castle Danger, but is encampment also a mining company with the same name as the location?
Yeah, I think that the location on the North Shore is not a site at this point that I know of mining, but I think that there is a real effort by mining companies to find names for their industrial efforts that sound natural. I mean, Talon Metals, I mean, they've been using words like Talon and Raptor because somehow I think they feel that that is a masculine version of nature. But they've named their deposit the Tamarack deposit, you know, naming it after an area that sounds good. And Polymet is now trying to combine with tech under the term New Range, with the idea of sort of getting the enthusiasm that has been for Minnesota's Iron Range. So I think part of this is using words like encampment and using words like Masaba. They're trying to incorporate and use the words having to do with nature or tribes as kind of a little bit of public relations. Other questions? You can just raise your hands too, or comments. If not, I think what we want to do is like get me out of my share. Get me out of my share. And then Eric, do you want to go ahead?
Yep, I'm here. I will go ahead and share my screen if I can.
I hope, Sophia, you can figure out how to do that, because I'm just going to keep my hands off the controls.
Well, that seems to have worked. That's good.
Now, if you can press the button for at the bottom for the full screen. Excellent.
Looks great.
Okay, so I'm really happy to be here tonight, and I was just thinking to myself as I was listening to Paula talk that I'm kind of surprised to be here for a couple of reasons. The first is that there's a real critical need for citizens to get out in the world and get water samples and get them tested for themselves. I was really kind of surprised to find that out, that how critical, how almost dire is the need for individual citizens to go out and take a look at what's going on in the world, and to do that through the lens of what are the chemical pollutants in the water. There's a need for it. There's always been a need for it. The need is dire. It's getting worse. And so I'm really surprised to have learned how severe that need is. But along with that, it's really ironic and also surprising to me that that our group was the first group to be accredited by the MPCA to go out into the environment and get water samples and have those tested for chemical pollutants. And Paula deserves a lot of credit for that, because she mentioned a couple of times the cumbersome nature of the paperwork and so on and so forth. It really was a lot of paperwork to work through, and that's what has prevented people from doing this in the past as much as anything. I think there's a need for how do you sample the water and the training and learning the right protocols, and that's a little bit foreign to people, but whether it's the cumbersomeness of the paperwork or it's the kind of, it's a little unfamiliar to some people, it just hasn't been done. So here I am to talk a little bit about what is that like, and hopefully I'm going to convince you that you really need to help, and it's fun. And so the thing that I really like about the water sampling is we learn about water. I know so much more about water in nature now than I did before. My background is as a chemist working for 3M and Ecolab, and I know about water from Ecolab's perspective and 3M's perspective. I've published papers and filed patents and issued patents on the quality of water as it relates to its use in industrial processes. What about the quality of water as it relates to our safety and the safety of our environment? That's what there's a lot to learn about, and we're learning some astounding things. And we're going to keep water clean by doing this. And we're supporting environmental groups. So we support WaterLegacy and Friends of the Boundary Waters and Save the Boundary Waters, and we support the MPCA. And maybe one of the most entertaining things that we do is we bust myths about water. I'll talk a little bit about that. We're protecting wildlife. There's a lot of wildlife that are high enough up in a food chain that they're affected by the neurotoxins and poisons in the environment. We're protecting people. We're, of course, the top predator. And the final reason is we're going to have some fun. So these are the groups that we support. And Paula's talked a little bit about Birch Lake. I'm going to come back to Birch Lake in a little bit. It's polluted. It's polluted from North Shore Mine, which is a taconite mine. This is a mining operation that's digging for rocks that is fairly low in sulfur content. And it's also, they're digging, an ore body where for every pound of metal, there's 2 pounds of waste tailings. This is going to change when we go to copper and nickel. When we switch to copper and nickel, instead of 2 pounds of waste for every pound of metal, there's going to be 99. And instead of digging for fairly low sulfur geological formations where iron is, they're going for the high sulfur copper nickel deposits. So this is Birch Lake. Birch Lake is polluted from taconite. It is under severe threat because of the copper nickel mining. And the thing that really upsets me is this water's all going to the boundary waters. It's all, the Birch Lake is a reservoir on the Birch River that flows into the Kawishwe River, and it all goes north, goes all into the boundary water. So all this pollution is going to a place that we really care an awful lot about. So here's one myth that's been propagated, and that is that, you know, sulfate pollution really doesn't have a lot to do with mercury in fish. And well, it does. The reason why people can construct this myth that sulfate and mercury in fish aren't really related is because it seems a little odd. If you pollute your water with sulfate, you get mercury in your fish. You know, I gotta say that again, it doesn't make sense. You put sulfate in water and you pollute the fish with mercury. That doesn't make any sense, but it is in fact true. It's accepted science throughout the rest of the world, but in Minnesota, it needs a little bit of help to understand this. I'll just say, for people who are wondering, how can sulfate in water put mercury in fish? Sulfate is a terminal electron acceptor. Oxygen is a terminal electron acceptor that we as humans use. When we breathe, we're burning fuel. The oxidation of that fuel comes from oxygen. If you're a sulfate reducing bacteria, you don't use oxygen, you use sulfate. And if you're a sulfate reducing bacteria that's using sulfate to burn instead of oxygen, you are methylating mercury and you're turning mercury into an organic compound, which fish bioaccumulate. So again, make no mistake about it. When you pollute the water with sulfate, you put mercury in fish. And the lakes that are the most susceptible to this kind of environmental damage are northern Minnesota lakes. And so this chart, okay, so this is a chart. This is from a review of literature done by the Northern Lake Scientific Advisory Panel. And what you can see is that on the x-axis, so we're talking graphing X and Y correlation, relationship plotting, there's a very good correlation between the sulfate in Lake Cabotogama, Namakan Lake, Rainy Lake, Sandpoint Lake, and Crane Lake. And these are all lakes that are in Voyageurs National Parks. This is data from the United States Geological Survey. The same data you can find in the Minnesota Pollution Control Agency's Fish Contaminant Monitoring Program database. It says that the closer you are to the source of sulfate pollution in Crane Lake, the higher your sulfate in the lake is, the more mercury you're going to have in your fish. And in the red zone, this is fish that's considered unsafe to be eaten. And we can argue about how many of those unsafe fish you can eat, but as Paula mentioned, people are eating enough fish from Minnesota lakes that 1 in 10 babies born in the Lake Superior watershed portion of northern Minnesota have unsafe levels of mercury when they're born. So as you move further downstream from Crane Lake to Sandpoint Lake, the sulfate drops a little bit and the mercury in fish drops a little bit. And further downstream, Rainy Lake and Namakan Lake, it drops even more. There's no doubt that putting sulfate into the water it should be restricted to 2.5 parts per million. And right now we're struggling to get people to respond to a 10 parts per million sulfate limit for wild rice. And we've got to hold the line on that. in advent of the day when we can get some more meaningful legislation that protects humans and other top predators. So this shows where that sulfate pollution is coming from. It's coming from Mintech in Virginia, Pike River through Vermilion Lake down the Vermilion River. And if you look at this, what you're seeing there in the little red boxes, and then they become orange boxes and eventually yellow boxes, is that's, you know, yellow light, red light, green light, stoplight analysis of how bad is your sulfate in the water. You know, it's starting at 29 parts per million in the Pike River, and it drops to around 12 in some places. In Lake Vermilion, it's about 7 when the Vermilion River leaves Lake Vermilion, and it gets diluted going downstream. But when it gets to Crane Lake, there's still enough sulfate in there to cause that problem that we just saw. And part of what we do as NLSAP is all this data that you're seeing on this slide of how this sulfate, where it comes from and how it gets diluted, that comes from NLSAP. I just want to say here that I'm going to talk about another myth. So a myth that we've heard is, and I think, Paula, you fell prey to this a little bit, is that, you know, sulfate in Birch Lake might otherwise be 2 to 3 parts per million. No, in Birch Lake, it's probably 2 at most. You know, you can get a little bit of sulfate in the water from roads and from cabins around there. But if you start looking at water in the boundary waters, in Stony River, in Cloquet River, in places that are not impacted by mining, it's always under 2. And yet the mining people, and Jason Metz, our favorite former representative from up north, will tell the Minnesota legislature, sometimes you get 25 parts per million sulfate in natural places like the Partridge River. That's not true. The reason we know that is because we've sampled extensively in northern Minnesota lakes that are not downstream from mines, and we know that it's always under 2 unless there's some human intervention. And this is another myth. It's under 2, mining raises it. Mining puts mercury into fish. Here's one of my favorite myth-busting activities. And so I think Bob Tammon's on the line here. This is a paper from the University of Minnesota in Duluth, and it says that methylmercury production in a chronically sulfate-impacted subboreal wetland is no greater than methylmercury production in an unimpacted wetland. And what you see in the left image here with the white arrow, looks like a little peanut, is the unimpacted wetland. But if you look at the yellow arrow in this satellite photograph, there's some kind of funny features on the landscape right there. And the question is, gee, that looks kind of funny. What is it? Well, Bob Tammon had a map of all of the mining infrastructure in northern Minnesota. And this yellow arrow corresponds to what is a place where they're depositing overburden. They're depositing waste rock from iron mines. And then so that's the middle photograph, is the mining features in northern Minnesota from Bob Tammon, his big map that he's pretty famous for showing. And the black arrow in the middle is the little peanut again. And then, you know, Bob took it one step further and said, you know, I've got a 1951 topographical map, and, you know, it shows the same feature, which is the little peanut. And, you know, as you can see, the little peanut is right next to a mine dump. But then, of course, what we do is we test water. So Bob went and got a sample here, and the sulfate concentration in the little peanut, the unimpacted wetland, is 5 parts per million. And that, if you remember from a couple of slides ago, puts it right up here. That's where methylmercury gets produced. And so really what this paper was really all about, and we find this out by testing water, is it wasn't comparing in an impacted subboreal wetland with an unimpacted subboreal wetland. It was comparing a polluted wetland to a polluted wetland. And now we know that. So we're helping to bust some of the myths about that by seeing for ourselves what water looks like. So I'm going to just throw this up here. Maybe I should have put this at the end, but I'm really encouraging people to join our group and to help us collect water. We'll teach how the water is collected. It's put in a cooler. It's carried around in tamper evidence bags. It's delivered to the environmental company that measures the sulfate. We don't do that. The report comes. There's a bunch of steps in there. What really is the fun part, and what is the part that we really desperately need more help for, is going out into the environment and getting samples. And you know, what's not to like? I've got some pictures of people in a group getting water samples. It's an enjoyable afternoon, and we're doing really great things for the environment. So we're going to have a training about, this is a lot about the, you know, the paperwork and what is chain of custody. You know, how do you preserve the sample, keep it cool? How must it be delivered or shipped or whatever to the environmental company? That's all kind of the classroom edition. And the lab is going to be the following day, and we're meeting at the Minnesota 135 bridge over the Embarrass River near Embarrass, and it starts at 9 o'clock. And then from there, we're going to go into different groups, all with a trained NLSAP volunteer to complete the field training. And I think we're going to, right now, it looks like we're going to be breaking into 3 training groups. Again, that's coming up pretty quick here. And what I'd like people to do is sign up. And here's some of our samplers here. This is Elliot and Adrian. They're on the Dunker River, which is the path. That's the river that the pollution from North Shore Mine flows down to get into Birch Lake. And this is the Dunker River again. This is the Embarrass River. And it's astounding, you know, how much pollution. We don't just measure the sulfate concentration, we measure the flux of sulfate. So we can go to a bridge and we can ask ourselves, how much sulfate is flowing down this river under this bridge in one day? And the tonnages of sulfate will astound you. It's not unusual to see 10 tons of sulfate go through a single culvert in a creek downstream from a mine. 10 tons of sulfate through a 5-foot diameter culvert in a creek in a single day. And just think about that, when it's 5 parts per million sulfate that causes contamination of fish, how much damage can you do with 10 tons of sulfate a day? This is why it's really important to get out and help us get those water samples. So on the left here, you see somebody, a very intrepid water sampler, haven't got up to northern Minnesota late in the year. It's a little snowy out. And you know, a good time nevertheless. So I encourage everybody to join us and do a good thing for the state.
You know,
Yeah, any questions?
there were a couple here. There was one question, whether a person can come on and join the sampling and learn what they need to know on May 13th in Evelyn, even if they can't make it to the event in St. Paul. And I think the other point is, isn't the one in St. Paul on the 12th also going to be virtual? So
It will be, yes, it will be.
Okay, so just the first point is, anyone who would like to do the actual sampling on the 13th and isn't going to be in St. Paul on the 12th, it's that part, since it's not hands-on, is designed to be a Zoom link. And then the other, I don't know yet. Then also, Eric, if you could, and Sophia, maybe you could explain both. Is it necessary to be at both trainings, and how do people sign up?
I'll let Sophia talk about how to sign up. I'll just say, here's what it would be like to show up on Saturday without coming on Friday, or not being able to attend virtually on Friday. Yeah, you can do that, and we can cover it all. But it's kind of like having a forewarning and a little bit of precognition, so to speak. It'll make what you're seeing out in the field when we're actually getting the samples, it'll make that so much more intuitive if you can make it on Friday, but it's not required.
Sophia, do you want to explain the sign up?
Absolutely. So for those of you who have been interacting in chat, you may have noticed there's a Google form link that's being shared. That link contains more information about both the May 12th and May 13th sampling opportunities and training. So if you are interested in participating in either or both of those sampling opportunities, please fill out the form with the link that I'm about to submit and let us know so that we can send you more information and make sure that you are connected with Eric and NLSAP to be able to participate.
And the role WaterLegacy is playing here, in addition to I'm talking today, we're going to make sure that Eric doesn't have to deal with Google Forms and all that technology, and Sophia will download all the information and sort of facilitate this process. So Eric is and his team are the experts. I know Bob Tamlin has done a lot of sampling too, but Sophia's there to facilitate it, make sure the connections work, and that NLSAP gets everybody's contact information and any questions you have. There were a couple people who had comments. There's I think there was a comment from Sid, who was asking also about sampling of tritium. I know I did before I worked for WaterLegacy, I did some work with folks in the Prairie Island area who were real concerned about releases of radioactive materials. I don't know what is entailed in sampling or whether anyone is on top of it. I know that when I used to work on that issue, it was quite frustrating because the community's concerns about the risks of radioactive materials was never really addressed. So if there's anyone here who's got an organization or their own work that is focused on the risks of radioactivity, please put your message in the chat so that Sid can get that and we can make sure to connect the people. I'm not doing that work any longer. The WaterLegacy is overwhelming.
Another question in the chat, this would be for Eric. How can I find an area I can get started testing? Do you have a map of sites needing citizen volunteers? I know we saw one slide about wild rice sites that need sampling, but is there any map of sites of different water bodies throughout Minnesota that need citizen samplers?
Yeah, so I don't know if I got my email or contact information in the chat, but that's probably a good question for offline, because I think it probably is going to depend upon where you're located. You probably want someplace either close to where you live, or I'm guessing maybe you've got a favorite spot up north that you're really concerned about. So let me know, and I'll look at that map. So when we are preparing our map of collection sites for 2023, it's a little bit like triage. We can't sample everything we'd like to sample. And I'd have to say that, beyond our triage, if your site isn't already on our list or on our map, it probably should be there. And if you attend the training, and you're capable to do this, you'll be able to go out after this and get water samples yourself from where you want to and handle them properly and take them to the environmental lab or ship them there. So I'd also say that, you know, in doing this, one of the cumbersome things that we have to do to get the MPCA to accept the data is a what is that? It's the, so we've got this
Project form, that's the hard one.
project description form, yeah. And
Chain
I
of
think
custody.
yeah, chain of custody. And I think we can add sites, but we have to do a location establishment form.
One of the things that's the most tricky is, and that's why I think it's really good to affiliate with someone like the Northern Lake Science Advisory Panel, is that if you're sampling in an area that the Pollution Control Agency has already identified for a sampling site, it's quite a bit easier. And then there's a distance within which you have to be from that site. And so part of it, the reason why it's good to have a nonprofit that's working on it, you can work under in affiliation, is to figure out in the water bodies you care about, where are the MPCA sites? How do you identify them with GPS? How far away do you have to be or close to them in order to use that site number? What is the way in which you have to measure the pollution, the pollutant you're concerned about? And then I think there was a mention about chain of custody. There's some sort of rules in how you identify where you are, how do you take the sample, and how do you get it to the lab so it can't get adulterated in the process. So there is some, I mean, some of this is just common sense, but a lot of it is sort of like making sure you take the steps in the right order. You know, you might want to go back, Eric, and if you're going to put something on the screen, and put the one that says sign up that has your email so that people can get your email again and just look at it.
Okay, let's see. Yeah, either yeah, this will do. You know, we're talking about, you know, establishing sites. You know, somebody asked in Duluth a couple of weeks ago about the Upper Cloquet River. You know, the Upper Cloquet River is an important site. We really want to get data for the Upper Cloquet River. But it's not, it was not on our radar screen, so to speak, because of the prioritization. But what we can do, what we'll do for this person is he'll be part of the training and he'll be able to get water samples in the Upper Cloquet River and be part of that. I think for me, I get a lot of satisfaction from getting water samples in the boundary waters. And there's a lot of lakes out there, and I think it, you know, this is going to be a little bit of a stretch to get the MPCA to do the site establishment for locations in the boundary waters, but it's really important. We want to take stock of, you know, what we've got and how clean it is and understand it today. And so I encourage everyone to think of their favorite lake, and it might be in the boundary waters. Go get samples.
We've got a bunch of questions. Here we have a question from Michael Maleska. Is it okay to bring a couple of recruits to the May 12th Zoomcast and or the field site on May 13th? Hopefully to become volunteers later, but to just get the education first.
Absolutely.
And I'm going to say that people, we reached out to our list, but if you have your own network of your friends, your neighbors, people who do the same, who care about the environment, just, you know, start the chain. This is the way it works best. And then Jackie Christensen is out in the field every other week monitoring with the Line 3 construction impacts. I think, and she's offering to add sulfate monitoring along the corridor. Jack, if you're still on, what else do you need from NLSAP or from Eric in order to add sulfate? Are you going to be able to, and are you going to be able to Jack, are you still here? I don't know. I'm just looking at a tiny little gremlin here. I think what we're gonna, if Jackie is not still on, if she had to go, I'm gonna ask Sophia if you could disconnect. Oh, there you are, Jackie.
Hey, yeah, I'm here. Yeah, I'm out in the field a lot, and doing water sampling. So yeah, depending on the sites, you know, of priority that you're looking at, if they are, you know, in the Fond du Lac vicinity, yeah, I mean, basically where the corridor, you know, within reason of where the corridor runs, I'm happy, yeah, happy to add that to kind of to my usual. And we do sample in the winter and in the summer. I'm curious, will this be, you know, summer ice-free sampling then only?
For the most part, it is. We'd like to extend it to year round for a couple of sites. So one, you know, interesting site is Spring Mine Creek. That's not in that corridor, but Spring Mine Creek is, it might be under snow and ice, but it's flowing underneath all year long. And it's important. I'm glad you asked that question, because as citizen volunteers, we can sample Spring Mine Creek in January. It's not scheduled to even be tested otherwise. And I think when you see 10 tons of sulfate going through one culvert on Spring Mine Creek in a single day, you realize that, you know, in a few days, you could have enough pollution to keep Embarrass Lake and Wind Lake and Sabin Lake polluted forever, for a long time. So I think, to your point, we really need to expand this testing, not just to more geographies, but more times as well.
And there is also a possibility that some of these companies are sluicing out water where it's less likely to, when it's less likely that it's being tested. I think the important thing, Jackie, is if you could join on the, just to get the information on how do you do the sulfate sampling, because you've got already Pace Laboratories. They will certainly know how to do their part of it. And then also how, maybe how to figure out where the nearest MPCA sampling site is, because many of these areas probably already have them. And I think this is wonderful. And all the areas that Eric was talking about, Spring Mine Creek, the Embarrassed, Sabin Lake, those all flow down to the St. Louis River. So they all affect the 1854 Treaty Authority, and they affect the Fond du Lac Reservation. And much of the impetus, at least for me, you know, which in working on this area, has really come from the knowledge and stories of the tribe. You know, and Fond du Lac was really the leader, and now there are many leaders in many of the tribes. Does that answer your question, Jackie? Okay. And then the other question from Craig Sturrell: what is the cost and who covers the cost? I'm laughing because the answer is not something you're going to want to hear. But of course, if any of the organizations on this call would like to create a little fund, we got a little bit of money, and Eric has refused to take it so far. So we've used it for things like this event. But I think that at this point, NLSAP is not in an 501c3, but if there's anyone who wants to adopt them, help them, that would be very much, I think it would be great.
Yeah, I can explain the funding a little bit, and I'll just say we do have the grant with WaterLegacy for training people. So there's some funding that's coming from the University of Minnesota through the University of Minnesota Extension. But we do pay the environmental lab to do the analysis of sulfate as individuals. And it's kind of like friends at dinner. It's like, okay, we've got a round of water samples that needs to be tested and paid for. It's like who's got this round, and invariably we have enough people say I'll throw in $100, a couple $100, or or I'll get this round, that we've never had a problem paying for anything. And the benefit of the friends going out to dinner mentality is that we would be free to advocate based on what we found. We're not beholden to anybody. I think that's really important, that one of the principles of NLSAP has been, again, kind of friends meeting together, and it's the data that we generate is for everybody. It's not just for the members of the group, it's for anybody that wants it. And people can take that information and they can do with it whatever they want. We do believe that I guess I'm speaking for myself. I believe that the path towards good environmental stewardship is just knowing. And people can look at information and they can decide it means different things. And I do have to say, some people, within NLSAP might think, well, gee, we found a really horrible lapse in this permitting. We found a mistake. We find mistakes in the polymet permit. There's geographical errors. And some people say, this permit is ineffective. It does no good. We can help fix it. And, I think they're maybe thinking about, we can help fix it on behalf of the mining companies. They made a mistake. They're going to get into trouble. It's bad for the environment. We can help. And there's other people that might say, gee, this is, we're doing this in staunch opposition to mining. It doesn't matter. At NLSAP, people do not have to check their opinions at the door. They're free to have them. They're free to take whatever data we collect and do with it what they will. And these are the features of not being a 501(c) is that people, for whatever it's worth, come as individuals and participate as individuals and are entitled to think whatever they want. And you don't get to think more if you pay more. we're kind of, kind of a democracy, I guess.
There was a question about, is there currently a public database on sulfate levels in Minnesota lakes? And the answer is yes, but it's not very easy to access. And I will put the online site in the chat. And it has both a way of searching by lake and by map. So depending on whether you're left brain or right brain. But I will say that it is challenging and it's a lot easier to use on a computer where you can actually download the spreadsheets. I think that it is, I have to say that the MPCA is really trying to make some of this information accessible, but they tend to have this style of information for professionals, and it makes it relatively hard, I think, for citizens to figure out.
And we can help with that. If you want to find information or, heaven forbid, figure out what's in one of those Excel spreadsheets, we can do it. This is an example of I mentioned the fish contaminant monitoring program database. Paula helped us get our hands on that through an FOIA request. We knew it's something that MPCA hasn't really advertised and made very public knowledge that it even exists, but it does exist. And what we knew was that, maybe 10 years ago, it was 30,000 records. So we got it, and, somebody from the MPCA sent it to me to look at, And by that time, it was 60,000 records, which is 60,000 rows in an Excel spreadsheet, if you can imagine. And 72 columns wide, 72 columns, 60,000 rows. What are you going to do with that? And here's where not everybody in the MPCA is, on the side of mining. The person who sent it left a clue about how to use filters and different features of Excel to get through it pretty quickly. That's the kind of thing we can help people with. If you're interested, in, things like mercury in fish, for example, the FCMP database Excel file, I can send it to you this evening. And when it befuddles you, you can call me up and I can show you what someone once showed me. It's fabulous because that database agrees perfectly with the USGS data for Voyagers Park. There's a serious problem with mercury in some of those lakes, and it's definitely correlated to the sulfate. So anyways, anybody wants that, just you can send an email to info@nlsap.org and I'll send it to you.
And I got a request, does WaterLegacy have sort of a compilation of all the really important articles? And the answer is no, but I think if you really want to understand how sulfate reacts with mercury and excessive nutrients, Amy Mirbo's 2017 article, which was co-authored by several of the folks at the PCA and the university, is really, I think, the most important one to start with. And so I put that in the chat and I really strongly recommend it. I'm looking to see if there are any other questions that we've missed or comments that we've missed. One thing I did want to say is, all in this struggle to get the wild rice impaired waters listed, there was somebody who will remain anonymous at the Minnesota Pollution Control Agency who, without listing the names of the water bodies, gave me all of the data that the Minnesota Pollution Control Agency has analyzed about water bodies that exceeded the 10 parts per million, and gave me the identification number for the lake or the stream, so that if I was willing to do the work to look up and find out what water body it was, which I could do online, that is how many of the water bodies were identified for the listing of impaired waters. As I shared that information, I analyzed it and shared it with the tribes, and that information got to the EPA. So there are many people within the agencies who are still scientists and still care about water protection, even if they sometimes have to do it without being very open and public about it.
Yeah, I'd add to that. The MPCA is definitely run top down, but that doesn't mean that people don't have their individual opinions. And a lot of people at the MPCA went to work for that organization because they wanted to protect the environment. They still do. And sometimes when we, kind of seem to be at loggerheads and we ask them, what about this? What they'll tell us is, you go do it. You go make a comment, because I can't. My job doesn't allow me to have an opinion on this. I do say that sometimes we kind of get like a cry for help from people within the MPCA, because they know that some of the things that we do are going to get them in a hot seat. And, someone from the MPCA was counseling me on how to do some testing. And, he's, telling me, that actually he told me he could remember every lawyer that's had him on the stand for, even thinking about doing a measurement like this. And then so he described one particular thing, and I asked, can you remember who that lawyer was that grilled you about that? And he said, oh yeah, it was someone from Polymet. The same person told me that, he's there to protect the environment and he wants to be out in the field. He doesn't want to be in a courtroom somewhere. So what we're doing as citizens is, we're more free to have an opinion one way or the other that we can express and write up in comments. And we're also, not likely to get, hassled in court. It's really wonderful that we can put the data on the database and, and yet, we're not really in the sights of, some lawyers that are going to try to, make our job unpleasant. So I think that that's another reason why this citizen water testing is really important, because we're free to do so. We can choose the lakes. We don't have to have somebody from a top-down administration tell us which lakes we can test and which ones we can't. When we test those, we can have an opinion about what that data means.
One more question from Chris, and then I think we need to wrap up. And that's that lakes in Canada have had a signs warning of mercury contamination for years and asking whether sulfate is the problem. I think I want to say that I want to make sure that people understand that there's also sulfate that is the problem that runs off of agricultural sites and ethanol production. But I think in Canada, there's also mining in Canada.
Yeah.
So I think we'd have to look at each individual area and find out what's the problem in that particular area. And it may be that the quality of the mercury emissions. I mean, we have in Minnesota a problem of uncontrolled taconite air emissions, and that's something that I think we're going to have some support from both the EPA and the Minnesota Pollution Control Agency finally after 30 years to start controlling those. But I think before making an assumption, I think we'd need to look at where's the individual lake and what are the air quality and the water quality inputs to see what's the biggest risk that's creating the mercury contamination. Any other questions for Eric before we go, other than go online, sign up, and please become part of a citizen crew that is invested in helping do the job of protecting water. And I wanted to say that people like Eric and Bob and all the other folks who've been working with NLSAP, they're really heroes, and please join the heroes. And Jackie too, who's also been doing citizen science. You guys are our heroes. Thank you.
Thanks, everybody. It's really great to be part of this evening.
Nice job, Eric, as usual. Take care.
Bye-bye.
Bye-bye, everyone.